Hi, this is Ms. Park, and in this video we will be solving quadratic equations by factoring. Okay, so I have to first tell you what this all means, solving quadratic equations. I'll remind you that quadratic relations, it's an equation that looks like a parabola, and it will look like this. Here's one in standard form, y equals ax squared plus bx plus c. Okay, that is a quadratic relation. We can graph it, we get a parabola, we can see vertex, x-intercept, all the stuff. Okay, quadratic equation, I'm going to write down the words, but I'm going to just leave a blank and fill it in a few minutes. Okay, let's say I asked you to graph or sketch a graph of a quadratic relation that is given in standard form. Okay, so let's say I give you this one, y equals x squared minus 4x minus 5. One thing I could do is complete the square. Okay, completing the square will give me the vertex form, and then I can put the vertex on the graph, and then I can find other points from the vertex. An easier way of graphing is graphing by converting to factored form. And to convert to factored form, we factor the equation. So instead of the standard form here, I can see this is a simple trinomial because in front of the x squared there's no number, which means there's a 1. So in a simple trinomial, I can go right to the brackets in one step. I'll put my x's in both brackets, and now I need to find two numbers that multiply to -5 and add to -4. And those two numbers are -5 and +1. Okay, and so now I've got this in factored form, which means I can see my x-intercept, right? This is factored form. I can see my x-intercept right from the equation in factored form. So they are 5 and -1, which means if I want to do my sketch, I'm going to put my x-intercept of 5 here on the graph, and I'm going to put my -1 here on the graph, and now I can find my axis of symmetry exactly halfway in between. Axis of symmetry, you go -1 plus 5 divided by 2, that gives you the average, and that's equal to 4 divided by 2, which is 2. So then my axis of symmetry is the line x equals 2. So at 2, I'm going to make this little axis of symmetry that's not really there. But now I know that my vertex is 2 something. And so I'm going to sub x equals 2 into the equation and get y equals 2 squared minus 4 times 2 minus 5. That's 4 minus 8 minus 5, which is -9. So now I know that my vertex is here. My vertex is 2, -9, and I can sketch my graph connected to the, pretend it went through the point there. There you go, and I sketch my graph, and I can write my equation next to the arrowhead, and I'm done. Okay, so that was really nice because I was able to factor it and get it into factored form and then read the x-intercepts right off of there. Okay, when we find x-intercepts, what we're really finding is we're finding these points here. Okay, so my -1 and the 5 are really -1, 0 and 5, 0, right? Those are the points with coordinates. And what we notice is that the y is 0 for the x-intercepts. So for the x-intercepts, y is 0. Just like if we wanted to find the y-intercept, we would make x equals 0. So the difference between quadratic relation and quadratic equation is that quadratic relation is y equals, whereas quadratic equation is ax squared plus bx plus c equals 0. Okay, it's different. Look how they look different. And the equals 0 gives us the x-intercepts. That gives us the x-intercepts. If I can find out where this parabola, where the y's equal 0, then I'm really finding the x-intercepts. And so the solution to a quadratic equation gives us the x-intercept. Another word for that is solution. Another word for that is roots of a quadratic equation. And another word for that is zeros. These words, x-intercept, solution, roots, and zeros, all mean the same kind of thing. And they happen when you take your equation and you set it to 0 and you solve. Okay, let me do one without graphing. So I'm just going to do a quadratic equation and solve it using factoring. So I'm going to just go back to my blue pen. Okay, and so I'm going to go example. Let's say I go y equals negative 2x squared. Sorry, I'm going to write it in the form of a quadratic equation. Okay, so I'm going to go like this. I'm going to say solve, and I'll write it like this. Negative 2x squared minus x minus 6 equals 0. So let's solve this. Solve it means find the x-intercepts, which really means the same thing as if I had y equals negative 2x squared minus x minus 6, how could I get the x-intercepts of this? By factoring. Okay, so let's do the factoring. This is a complex trinomial. Okay, one thing we can do here is to get rid of this negative in the front. We could multiply every term by -1. Multiply by -1 to remove the negative in the x squared term. Okay, just so that this doesn't, you don't think this says x minus 1. It says multiply by -1. So let me just fix that. So multiply by -1 to remove the negative in the x term. And I can do that by multiplying every term by -1. That's going to change all the signs. Sorry. Yep, oh, that's right. And then 0 times -1 is just 0. Okay, so that's a nice thing to do if you're starting with a negative. You could do it this way. Actually, I made a mistake in the question. This should be a plus, and this should be a minus. Sorry. Fix. Okay, so now I have this. Now we're going to factor. So it's a complex trinomial. So we're going to use the method of decomposition, or you could use an area model. Decomposition goes like this. I need to find two numbers that multiply to the AC. So first coefficient times the last one. So multiply to -12 and add to the B term. Okay, add to 1. And so I look at what goes into 12. Well, I got 1 and 12, 2 times 6, 3 times 4. 4 times 3 is going to be the same as 3 times 4, so that's the end. Okay, and I need one pair that's going to multiply to -12, which means one of the numbers in the pair is negative, but they have to add to +1. So that's going to be this 3, 4, but I have to make the 3 negative, so they add to +1. So now I got 2x squared minus 3x plus 4x minus 6. I am decomposing the middle term into the two parts, and now we're going to common factor each of the two parts. So I have x times 2x minus 3, and there's a common factor here of 2 times 2x minus 3 equals 0. And now I got 2x minus 3 is my common factor of the whole thing. I'll put it out front, and I'm left with x plus 2 equals 0. Now that I'm here, I want to make this equation true. So we use this it's called the zero product principle. I have here two numbers that multiply to give 0, right? The first bracket times the second bracket gives 0. And in the world, anytime you multiply two numbers, the only way to get an answer of 0 is if one of those two numbers is a 0. So if the product is 0, then one of them must be 0. That's the only way to get a 0 product, okay, is if one of the things you're multiplying is 0. So from here, I have two options. Either the first one is a 0, or the second one is a 0. All right, and in the case of the first one, I can solve it. Just bring the 3 to the other side and divide both sides by 2. And the other side, you can bring the 2 to the other side and have x equals -2. So the solution to this quadratic equation is two numbers. X is 3 over 2, also x -2, so two numbers. And if I was to sketch this on a graph, I would have two x-intercepts, one at 3 over 2 and the other one at -2. Okay, and then my axis of symmetry, I could do the same thing, find out where it goes. It's kind of halfway in between, and do the same routine, except now that you have fractions. Okay, let's do one more example of solving by factoring. Okay, so here's the last example. So 3m squared plus 7m minus 6 equals 0. Okay, so we're going to factor this, use decomposition. I need two numbers that multiply to negative 18 and add to positive 7. Let's see what goes into 18. 1 times 18, 2 times 9, 3 times 6. That's it. Oh, 2 times 9 works. Okay, but they have to add to positive 7, which means the 2 will have to be negative. 3m squared minus 2m plus 9m minus 6 equals 0. So I've decomposed the middle term, the 7m, into two parts, right? Factor this, 3m minus 2 plus 3, 3m minus 2 equals 0. And now I'm left with 3m minus 2 times m plus 3 equals 0. In order for those two brackets to multiply to 0, one of them must be 0. So either 3m minus 2 is 0 or m plus 3 equals 0. In the case of the one on the left, 3m equals 2, so m equals 2/3. In the case of the one on the right, m is negative 3. So we have two answers. Okay, and that is solving by factoring. Please practice. Thanks for watching.